Okay, so we're going to go over, we were in 8.2 and yes, we're in 8.2. We're talking about parallelograms. Okay, so let me send this to Olivia. I apologize. Okay. All right, so let's go ahead and get started. I should have my full attention now, trying to get everybody online. Okay, so we're talking about parallelograms, and just a quick review of parallelograms. We talked about some theorems on Monday, and I failed to put 8.5 on here. But a parallelogram is basically a quadrilateral. So quadrilateral means four sides, okay? And it has both pairs of opposite sides are parallel to each other. Let me make sure I keep my chat up on here. Sorry for the crazy screens. Here we go. So we have some examples of parallelograms here on the top of our screen, right? There's actually three theorems that have to do with parallelograms, and I think they make a lot of sense, right? If a quadrilateral is a parallelogram, then its opposite sides are congruent. So these two sides are opposite each other, they're congruent. These two sides are opposite each other, and they are also congruent. Okay. The second theorem, 8.4, is that opposite angles are congruent. So these two angles are opposite each other and they're congruent, and these two angles are opposite each other and they're congruent. And the third theorem, 8.5, which I don't have on here, is that the consecutive angles, so P and Q, okay, are supplementary, which means that they add up to 180 degrees. Okay, so then we did some problems with that. I think everybody thought that was pretty easy. We did these two, everyone was good, right? And then the new theorem that we have today is that this is 8.6, if a quadrilateral is a parallelogram, then its diagonals bisect each other. Okay, so let me pull this over into Paint. Okay, so the fill in here is if a quadrilateral is a parallelogram, then its diagonals bisect each other. So what does the word bisect mean? I guess you guys can't chat back. But remember, bisect means that they're going to cut each other equally in half. All right. So if you look at the line from Q to S, okay, that's my line. It's bisected at point M, and that means that from Q to M is equal from M to S. Okay. I also have line PR. Okay. PR is when they intersect, right? They intersect at M. So that means that it's bisected at M. And so that means P to M is equal to M to R. So if you want to fill in the blanks here, QM is congruent to MS. Okay. And PM is congruent to MR. So this is a pretty easy little theorem, and you can see the problem that goes along with it is pretty easy too. Given that FGHJ is a parallelogram, okay, and they tell you that FM is 5, find MH, and FH. So since this is a parallelogram, and these are the diagonals, then we know that this line, this diagonal bisects each other. So if this is 5, that means that this has to be 5, right? So MH is 5. And that means that FH, the distance from F to H, is 10. Okay? So that is kind of the rest of 8.2. So now we're going to talk about 8.3. Okay, and this kind of is the opposite of 8.2. So in 8.2, we started off with, we have a parallelogram, so we know the opposite sides are congruent. So these are basically the converse of 8.3 and 8.4. So this is basically the opposite of theorem 8.3. And this is basically the opposite of theorem 8.4. Okay, so this says if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So if you remember in 8.3, we said if a quadrilateral is a parallelogram, then both opposite sides are congruent. So this is just the opposite theorem. So we like that. That makes it nice and easy. It's the same thing. We don't have to remember anything, right? So if line AB is congruent to line DC, if line AB is congruent to line DC, and line BC is congruent to line AD. Oh, that's a really bad A. AD. Trying to write with a mouse. Let me write with my finger here. This should be better. AD. Oh, that's worse. All right. So basically, instead of getting messed up with my bad writing, we'll write it like this. AD. That's much better. This is the exact opposite of theorem 8.3. Okay. And then 8.8 is the exact opposite of 8.4. So this says if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So if angle A is congruent to angle C and angle B is congruent to angle D, then ABCD is a parallelogram. So again, same theorem that we learned in 8.2, but it's just the opposite theorem. So that's always nice when they're the same theorem, they mean the same thing. It's actually pretty easy to do, right? I think so. Okay, so let's solve this real world problem. We've got a basketball hoop. Where's Ruben when we need him, right, with basketball? In this diagram, A, B, and DC represent adjustable supports of a basketball hoop. So have you ever seen those basketball hoops that go up and down? You can kind of move them up and down. Explain why AD is always parallel to BC. So why is AD always parallel to BC? So we want to know why is this side always parallel to this side? Okay, so why are they always parallel? Well, let's look at what we have labeled here. We have a shape that appears to be a parallelogram, right? And we just learned a new definition, right? That tells us if both pairs of opposite sides of a quadrilateral are congruent. So do we have congruent sides? Well, yeah, DC and AB are congruent because they're both 36 inches. And AD and BC are congruent because they're both 18 inches. Then this is a parallelogram. So I can say because AD is congruent, and I'm gonna have to add all my lines in later. AD is congruent to BC, right? And we know that AB is congruent to DC. Then by theorem 8.7, we can say that it is a parallelogram. Now let me go back in and add my lines, right? AD and then the little congruent to BC. AB is congruent to DC. Okay, so by theorem 8.7, we can say that it is a parallelogram. And by the definition of a parallelogram, right? From the definition of a parallelogram, AD will always be parallel to BC. That's supposed to be a D. AD will always be parallel to BC. All right, any questions about that? I think that's pretty easy. But wait, there's more theorems. Just when you thought we couldn't have any more theorems about parallelograms, there's more. 2 more theorems, and then we've got a bunch of different problems here to go through. All right, and make sure you put these on your theorem sheets as well, because there are a lot of parallelogram theorems, so make sure that you have them all written down. Okay. Theorem 8.9 says, if one pair of opposite sides of a quadrilateral are congruent, and parallel, then the quadrilateral is a parallelogram. Okay, so this is a little bit different. Before we were talking about, we either knew the sides were equal and so that was a parallelogram, or it was a parallelogram so we knew the sides were equal. Here we have a little bit of both things going on. Okay, so here we have that side BC is parallel to side AD, and side BC is congruent to side AD. So we don't have to have 2 sides always, but if we have one side that they're congruent, oops, go back. We have one side that is, try to draw this nicely, congruent. It's my best congruent. And also parallel. So, oh my, parallels, 2 straight lines, parallel. I'm not having a good drawing day today. Just be straight. There we go. There we go. There's 2 parallel lines. So we only have to have, if we have one side that's both congruent and parallel, then it is a parallelogram. Okay. And then theorem 8.10 says, and this is kind of the opposite of let me go back. This one's kind of the opposite of 8.6. If the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So if BD and AC bisect each other, then ABCD is a parallelogram. All right, so now you have a ton of different, and again, this one is the opposite of 8.6. Let me double check, 8.6. This is the opposite of 8.6. Okay, so then let's do a couple problems with this and we'll be done for the day, all right? So let's do the last page here. Oops. Okay, example number 2. The headlights of a car have the shape shown at right. Explain how you know that angle B is congruent to angle D. Okay, so we have these headlights and we want to know, how do you know that angle B is congruent to angle D? Well, what we have is we know that BC is parallel to AD. We know that they're parallel because they have these little arrows, right? That tells us that they're parallel to each other. We also know that BC and AD are congruent to each other because they have these little hash marks, right? So because of theorem, sorry, because of the theorem that we just learned, right? Because of theorem 8.9, we have that we have two sides are congruent to each other and the same two sides are parallel to each other. So because of theorem 8.9, we can say that this is a parallelogram. Okay, and then because it's a parallelogram, then we can use theorem 8. Does anybody know? 8.4, way back in 8.4, it says if you have a parallelogram, then its opposite angles are congruent. That makes sense, guys? So basically, we have these two sides, AD and BC, that are both congruent and parallel. So by theorem 8.6, we can say this is a parallelogram. And then because it is a parallelogram, then by theorem 8.4, we can say that our opposite angles are congruent. Okay? Hopefully that makes sense. Hopefully you guys are with me. All right. Oh, good. Olivia's with me and she's here. Yay. I will start sending it to your other account. That was the problem all along. Okay, checkpoint number 1. In a quadrilateral, GHJK, measure of angle G is 55, measure of angle H is 125, and the measure of angle J is 55 degrees. find the measure of angle K, and then what theorem can you use to show that this is a parallelogram? So this one, they don't give you a picture, but we can figure this out. We can do this. Can figure out if this is a parallelogram. So I am actually going to draw, I don't know if it'll let me draw a nice shape like that. Let's see. Well, it's not going to let me draw it if it's white. Okay. Let me try to draw a shape that looks like this. Okay, better than my freehand drawing abilities here. Okay, that's supposed to be a little more equal than it is. Okay, so we have some shape, and it is G, H, J, K. G, H, J, K. We know the reason that I drew a four-sided shape is that it tells me that it's a quadrilateral. So a quadrilateral means four sides and four angles, right? We know that the measure of angle G is 55 degrees. Okay. We know that H is 125. We know that J is 55 degrees. And we don't know what K is. But we do know that all of the angles in a quadrilateral always add up to 360 degrees, right? So if I add up the measure of G, measure of angle G, plus the measure of angle H, plus the measure of angle J, plus the measure of angle K, they have to equal 360 degrees. Okay, so I have 55 plus 125 plus 55 plus the measure of K, and I'm just going to make my paper bigger, and that equals 360. So if I do the math, okay, I add up 55 plus 125 plus 55, and I subtract it from 360, I get the measure of angle K equals 125 degrees. So this is 125 degrees. So now what do I notice? Well, now I notice that angle G is congruent to angle J, right? And angle H is congruent to angle K. So I have opposite angles. Both opposite angles are congruent to each other, right? And I have a theorem about this. If you look back on your sheet, hopefully you filled it in. And if you look at theorem 8.8, okay, theorem 8.8 says if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So because of theorem 8.8, I can say that it is a parallelogram. Okay, two more. This one says, what theorem can you use to show that this quadrilateral is a parallelogram? So you have this shape, and then you have two lines sorry, my brain. You have two lines that are the diagonals, right? You have this line that is the diagonal. So I can draw a line straight. And this line is a diagonal. And what you notice about the two diagonals is that they do bisect each other. So this side of your diagonal is congruent to this side, and this side is congruent to this side. So because I know that I'm dealing with diagonals, I know that this is either theorem 8.10 or 8.7, and they're giving me that the diagonals bisect each other. So this would be theorem 8.10 tells us this is true. Okay, and then last example here, we have a shape, and it says, for what value of x is quadrilateral PQRS a parallelogram? Well, again, these are diagonals of the parallelogram. We know that this diagonal already equals each other, right? These are equal to each other. So in order for this to be a parallelogram, then these two sides also need to be congruent to each other. Okay, and so if I want that to happen, I need to have that my one side, here I should write it without the letters. I need PT to be congruent to TR. And in order for PT to be congruent to TR, 5x has to equal 2x plus 9. And so then I just solve this. I subtract 2x from both sides, and I get 3x equals 9, or x has to equal 3 in order for this to be true. Okay. So on the bottom of your notes is this nice little chart. Okay. And so here it kind of wraps up all of those theorems that we did in this little section. Okay. So it says that ways to prove a quadrilateral is a parallelogram. So you could show that both pairs of opposite sides are parallel to each other, because that's the definition of a parallelogram. We can show that both pairs of opposite sides are congruent. We could show that both pairs of opposite angles are congruent. We could show that one pair of opposite sides are both congruent and parallel. Or we can show that the diagonals bisect each other. So those are all ways, if we don't know if something's a parallelogram, that we can prove it is a parallelogram. Okay? So this is just like a nice little review of all the ways that you can show something's a parallelogram. And that is all I'm going to do for today. So on Monday we'll talk about 8.4. Show a quadrilateral is a parallelogram. So these are special quadrilaterals that are also parallelograms. That'll be exciting, right? So thank you guys for joining today online. If anybody has any questions, I can stay on and answer questions. If not, you guys are free to go. Have a good day.